So let's get into some real-life examples. This is a house in Ann Arbor, Michigan that was done, and it was actually a pretty awesome job that was part of the Living Building Challenge, and was a deep green project, I believe. And in this house, we did a geothermal radiant heating. There's 60 PV solar panels on the roof facing south. And so during the winter, we're doing forced air heating as well for the shoulder seasons, and forced air cooling, and also potable hot water preheating on that with that superheater system I was talking about earlier.
Hey, Kyle, while we're talking about the potable hot water, there have been a few questions about these superheaters and whether or not you also need a water heater in addition to those. If you just want to briefly maybe touch on the different types of products while you're on that subject that will provide either 100% of the hot water or just that preheat option.
Yeah, okay, absolutely. So, well, no, you only need one hot water heating tank. To be perfectly honest, we find that when the EPA kind of forced us to switch over from R22 refrigerant to R410A refrigerant, that we lost some efficiencies out of our desuperheater function. It's just not as an efficient of a refrigerant. Therefore, we don't push it as hard as we used to. But our main shipping item is a unit that has a built-in desuperheater into it. There's still plenty of heat to come out of a system, but we believe that in the future, depending on how much water consumption a home or how many people are located or live in a home is to be evaluated. And let's say if it's a family of 4, you may actually consider not just doing a desuperheater. You actually may consider doing a hydronic heating unit that has a double wall heat exchanger on it for potable hot water that will give you your potable hot water 100% throughout the entire year. So that's an option as well. Back to a desuperheater, you don't have to just do that in 2 tanks as well for the optimal situation. We also have lots of questions about tankless hot water heaters. First of all, you don't have to use a desuperheater, and you can just use a tankless hot water heater. But if you really want to get the most bang for the buck, you actually should use a preheat tank and then the potable hot water heater, so that the incoming water into that tankless hot water heater is much higher, and that way that tankless doesn't have to hardly work to get the temperature up. So I've had tons of conversations with people and their experiences in regards to hot water and tankless hot water heaters, for example. Just evaluate what is the best fit for that consumer. I have a friend who we suggested a tankless hot water heater because he's going to be a bachelor forever, so he did not need to heat hot water much. However, another gentleman told me that his bills quadrupled with a tankless hot water heater because he had 4 daughters that took showers forever, he said. So there's just different ways.
Can you quick speak to, this is a question that came up and I had it too, can you quick speak to also the electric heat pump water heater being integrated?
Being a heat pump hot water heater, I think.
Yes, absolutely.
Yeah, so in that case, it's just, I think I would treat that just like they're a funny situation depending on the product that you use for a heat pump hot water heater. Because they're an efficiency loss. They're a heat pump themselves that are an air to water heat pump themselves on the small, as a micro size. So whenever it's heating hot water in the winter, it's actually dumping cold air into the space that your heating and cooling system just heated. So it's a conflict of interest, if you will, or it's the negative that you're taking heat out of the space you've already heated and putting it into your hot water heater. You know, Brett, a topic that we could get on is that in the future, because there's some products coming available that they would be hooked up to the end of an ERV before that heat loss is sent out of a house, and you can actually duct into that to grab onto that last little bit of heat for your heat pump hot water heater. But that would work in the same situation, simply put, where you have a preheat tank next to a standard hot water heater that's turned off next to your heat pump hot water heater, so that it's still preheated coming into that hot water heater.
Great, thanks.
All right. So to continue on, as I digressed, but the Ann Arbor, Michigan home here, this is just another image of the south face of this home where they have their PV panels array, and then the what we call a geoanalyst report, where we actually, our contractor up there, did a design on this system where he figured out the load of the system, and then he plugged it into the geoanalyst software to figure out what size of geothermal system he needed, how big a loop he was going to have, and what his run hours were going to be on that system. So by using a geoanalyst report, we can actually design the system to figure out the runtime hours that a system is going to have. And back to that step number, or back to that pie graph earlier, when we were talking about the heating, space heating, and the hot water heating, we can cover a huge chunk of what the expectancy is out of the system to help the PV solar side, help them design and size their system after the fact as well.
Yeah. I just wanted to jump in too and say this is also a LEED Platinum certified project, which is, you know, a cakewalk compared to Living Building Challenge. But you know, I think right here is one very important feature is the heating and cooling and duct sizing, and even in this case loop sizing, load calculation that so often gets missed or is done at the end of the project rather than at the beginning, to help ensure a right-sized system. So it's real important to do this, you know, and it is required for LEED projects.
Yeah, absolutely. Even we're seeing a lot more polished concrete floors as well, which helps you with those LEED certification numbers as well. And that they work so well with those radiant systems too, to where there's a warm, solid or finished surface right there as well. All right, so this is a job I have quite a bit of familiarity with myself. This is Ohm Sweet Ohm project up in Minnesota, and this one, simply put, was designed to, I'm not sure if this is an ICF home or not, but it's a very tight home, and it has geothermal doing forced air heating and cooling, as well as radiant heating and cooling, and domestic hot water for 100%. And after those 2 points, then they have their solar array, making this home a net zero home. But the kicker on this job is actually that the couple has 2 Tesla cars. And after they charge their 2 Tesla cars, they are still net zero. And I think that is such an awesome design, and what a cool concept, and it's something that's truly the couple is very, very passionate about. And there's actually a video that was done that I would encourage you all to watch, and Brett, maybe we can send that out as a follow-up. But just the emotion, the raw emotion that the couple feels about their home, and how proud of it they truly are. So in this case, as I said, they have some outstanding ventilation systems in their house. They have the hot water system as well, and a 18.91 kW array, and they they are producing more than they were using. This next project is actually, it's kind of a fun concept. This is a project that we're involved in Purdue, at Purdue. And it was a house that was built back in the 20s, and the college engineering team has been redoing this job with Whirlpool as being the lead. And they've been working with multiple manufacturers to create, I'll call it an alliance, to be able to show how you can take an older home and turn that home into a net zero home by using geothermal, by using high efficient appliances such as washers and dryers and other appliances as well to get a home to that point of being net zero. So here's some more collateral that Whirlpool uses with this home as well. Brett, I believe, asked us in the past week. We were talking a little bit about where does geothermal work, how does it apply to different buildings and structures. What about multifamily living? Well, no problem. So we do lots of designs in multifamily living, high-rises, whatever it might be. But in this case, we were part of a project that was in, I believe this job was actually technically in Provo, and it was a low-income facility, and it had 3 or 4 stories of apartments, and then it also had a decoupled building for townhomes. And we did a centralized looping system in multiple pods. I'm calling them pods because they did, I can't remember how many boreholes per pod, but I think it was about maybe 20 or 30 boreholes per pod, and there was multiple of those. And so basically what we did was every apartment had a small unit itself, and then we had a centralized pumping system that was a redundant variable speed pumping system that circulated the fluid through each apartment and townhouse, so that it was the most efficient that it could possibly be. And then on the redundancy of the variable speed pumps, they actually communicate via Bluetooth, and they work together in tandem to be as efficient as possible and increase their longevity so that there's not too much of a runtime. So this is a really fun project to be a part of, help the design process. And when this project came to us, it was actually misdesigned. The application was not put in properly for what the equipment type should be, and we helped them through that process to actually get the right package units into each apartment to have a great outcome. Brett, I think I'm going to hand it over to you on this one. I'm not too familiar with this home in Minnesota myself.
Yeah, so for those of you who want to stick around a little bit longer, we're going to actually take a quick deep dive into an energy modeling exercise on a real project, and then we're going to get to some more of your questions a little bit right after that. So this is the Minnesota Net Zero Victorian Gut Rehab. It has certified under the International Living Future Institute Zero Energy Certification, as well as our internal Zero Energy Hero Awards, which is an ongoing award each year that you can get for being zero. And it's hopefully just on the cusp of LEED Platinum and Green Star Platinum certification, as well as Zero Energy Capable certification. 3,400 square feet, downtown Minneapolis area, and about a HERS index or so of -9. What are the three, besides the heating and cooling, some of the major components of this is a very, very large 17 kW array here that you can't see, but this is a massive roof line up here facing south, and then on the garage. The house exceeds code by tightness, as well as the what I would say old passive house standard, which is now measured a little bit differently, but as far as air tightness, which makes a huge difference in the cold weather climates. And then it uses the persist method of exterior insulation, which we'll do a session on sometime here soon. But besides durability, that improves significantly the walls and the roof, and really just insulating and air sealing, as well as triple glazed windows. So it's a really tight envelope. They really did the right thing when they did the gut rehab process. So now you can see here, this is a snapshot of the performance. Actual energy use during the reporting period of mid-2016 to 2017, 12,000 or so kilowatt hours of energy consumed, and then 17,000 produced. And so we've got a net of 5. And one of the goals of the project was to also be able to power, to some degree, electric car. So this is including somewhat electric car. And then there's the EUI right there. And so what we did is we took, and anybody can download this. You can download a trial of it, or ideally work with your local energy rater. But you can download REMRate Lite, a trial of it, and you can dive into it right now for your own projects. And what we prefer is the DOE Zero Energy Ready Home report. So this program generates a ton of different reports, millions of reports, reports all day, lead reports, you name it. But this one, even though this project did not pursue the DOE Zero Energy Ready program, we find this to be the most helpful report, because down here, and we'll send out the handout, but it predicted about a negative 4,000 kilowatt hours of energy per year is what it predicted when all said was done. And so that was a HERS index of 29 without solar, negative 9 with solar. And you can just see how close that was to what its actual performance was. And I believe the year 2016 to 2017 data actually was a bit of a mild winter. So of course they're going to do better than what's predicted by the tool, which uses localized weather patterns. So what we wanted to do was just kind of show how this project needed geothermal to hit zero energy. So we took the best of the best ducted air source heat pump system with backup heat in case there was low temp, but then also it works down to really negative low temps. And we found about, we did a report there. So same project, same building file through REMRate, and we just swapped out the heating and cooling system for a heat pump. And then we also looked at a furnace and AC and did the same thing there. Now, when you do the furnace, it produces positive therms, and so you need to go online to some kind of unit conversion, and you've got to convert therms over to kilowatt hours. And you'll see that nice little unscary number of 342 suddenly becomes 10,000 kilowatt hour a year load on your project. And I don't think REMRate does that for you right now. They definitely need to. So here's what we got. On the same home, same place, same location, we got with a 98% efficient gas furnace, top of the line, 21 SEER AC, really, really high numbers. We got a positive 4,000 for the year. We still got a negative 5 on the HERS index rating, still got a 33 without the solar, and still got about 24 lead EA points, which is a lot. Now, with an air-to-air heat pump, with the top-of-the-line air-to-air heat pump, we still came out slightly right into zero energy capable, as we call it. However, again, the client's goal was to have an electric car, so that, could, depending on the weather and everything, could, risk that zero energy. And then so we got a negative 1 HERS index rating, 37 with no solar, and 24 lead points on that. And if you're just interested, these were the inputs we used for the top-of-the-line ducted air source heat pump system within the ResNet protocol. And then again with Geo, you can see you've got that nice negative 4,000 net positive cushion there to help supply with the electric car. And in Minnesota's case, if you overproduce energy to a certain extent, you get paid for it. Unlike other states or Michigan, you don't so much. So I also wanted to show this is a large home, 3,400 square feet. So what if we just shrunk that down to, all things being equal, shrunk it down to a 1,500 square foot home with 2 bedrooms. We just assumed that we would lose 50% of the fenestration. So, more windows mean more heat loss. So to be fair, we cut that out. in the Redden tool. And then we also we just assumed half the roof size, so therefore half the solar output. Doesn't necessarily work 100% that way, but it's pretty close. And so, what we found was with losing all that solar, to be honest, we went up to a 6,500 energy consumption of kilowatt hours after converting for gas on the AC and furnace. And then we also went not zero energy anymore with the air-to-air heat pump exchange. And then so for Geo, we still maintained that nice cushion of a predicted 1,000 kilowatt hours of net positive energy for this house at a smaller size with less solar, and still a -4 on the HERS index rating, where the rest of the projects both lost speed points and significantly took hits on their HERS index ratings. The other thing we wanted to do was take the same house, same location, and kind of make it more like the conventional home project. So not every project has the funds or the capacity to do a persist wall system, as much as we'd love to see that happen. So for the most part, not doing a full-blown gut rehab would actually kick this project out of LEED for the most part. And then also most existing homes have 12 inches on center instead of 16 inch. So we converted that. And then instead we just said, what if they just did 3.5 inches of blown-in cellulose or blown-in fiberglass? And then that way the HERS rater would have to give it a poorer rating because they wouldn't be able to see it. And so that's a typical thing. Most homes just don't have the money to insulate their walls, or they don't plan on changing the siding anytime soon. And so really, you really got to rely on that HVAC to drain your energy there and the solar. So with AC and gas, we had a predicted nearly 20,000 kilowatt hours positive a year, nearly 4,000 with the air source heat pump, but still with the geothermal energy, we still maintained a near negative 2,000 or net positive usage on this same home if it did not do the full system. So again, this is all theoretical, but this was the REM tool that we used to do that. All right, so that is the end of our recording, and session, and I'm gonna hand it off to Kyle here. I see some dialogue on the chat, and then we have some more time for questions if you can stick around.
All right, Brett, thank you.
And also, while we're waiting for those questions to come in, I did want to say a big thanks to all of our sponsors who allow us to do what we do, and our members, our board of directors, all of you for showing up to these sessions. To get your CEUs, make sure you check your email, check your spam, take the survey. For those of you listening to this in the future, make sure to take that 10-question quiz with an 80% passing rate. All right, sorry, Kyle, back to you.
No worries, no worries. Yeah, I have been trying to answer a few questions here. Mark, yeah, you're the man on that one for sure.
Kyle, can you share some of the maybe the big questions that were popping up that we didn't answer yet, just for everybody's sake?
Yeah, I'm trying to scroll through them. I was in the midst of answering answering. On heat, here's a question that was not answered from Timothy. Can you quickly review a bit on heat recovery? I guess I'd probably need a little bit. I could go in various ways. So it just depends on what we're talking about. But maybe you're talking about the ERV side of that.
I think he's actually talking about, you had mentioned there's heat recovery systems integrated with water heaters, and I personally never heard of anything like that. So maybe you could just reiterate that.
Yeah, that's actually, when I say on the back side of an ERV, actually the exhaust side of an ERV that would be going to the exterior, that would be gotten rid of. There are products coming, and this is a little hint, but there are products coming to where it will be called an exhaust air heat pump. And technically that Ream product that I was referencing earlier, you could actually do so with that product. So you would actually want to duct into the exhaust side of that ERV of that unit with your heat pump hot water heater, because you would be grabbing onto that last little bit of wasted heat energy that was going to leave the home and dump that into your hot water heater. You would actually pull out enough heat through that heat pump that it could actually take that energy and dump it into your hot water heater. So it's that one little bit of that last grab of energy so that it's not wasted. But I think that's a topic I could put together some slides on, and that I could actually show you some graphics on how that would apply and how you'd work that.
So the question I had was for LEED for homes and multifamily and mid-rise, we're required to, or project teams are required to give the owner and the building manager, homeowner, and tenants, quite frankly, sort of an operations manual, right? So you buy an appliance or a car, and it tells you how to operate this thing and operate it so it's, energy efficient and healthy. Now, most green building programs and LEED are saying, give me an easy-to-understand manual that helps me, operate my house or my project or manage my building better. And I'd imagine the HVAC system is going to be a massive part of that. So tell us a little bit about how, geothermal education and awareness and makes it easier, I guess, for building operations to help keep buildings efficient and healthy.
Yeah, I think that really starts with that step number one of insulation. Something that I've always believed in is those the thermostats that have a memory of what was, what your designs or what your set points are that you set it to, and they will continually program to that. I believe those aren't going to save you very much money in green building, because in green building you really want to set the temperature at what you feel is comfortable at and leave it there. And we feel the same way about heat pumps. And just leave it where you want it and walk away from the thermostat. That's the best way to efficiently run the system. Now, if you have a drafty house, for example, yeah, sure, you need to probably adjust the thermostat up and down throughout the day. But for a tight house, I see personally no reason other than comfort to adjust that thermostat. And my kind of analogy is take a gas-powered small sedan and you take it in a city block and you go stoplight to stoplight, and you speed up to 40 and you stop, speed up to 40 and stop. But if you take that same car, you put on the interstate at 70, it's going to have much better gas economy running at a slower speed or a lower RPM rate, and it's going to perform a whole lot better.
Can you speak to a little bit about just the maintenance required on geosystems?
Yeah, thank you. It depends on how you set it up, but just so I don't stick my foot in my mouth, but geothermal systems only require you to clean your filters. There should be no maintenance required. There's certain applications where that could be not true. For example, if you had a hybrid system with a furnace, you would probably want to clean that furnace out on a service plan, a service agreement. Or an open loop, for example, would need some maintenance every couple of years to probably decalcium, or what's the word I'm looking for here, to clean out the heat exchangers from calcium buildup or anything else so that you could wash that out. But really with geothermal systems, to put it bluntly, there is none. Just clean your air filters. A huge benefit to us is two-part. Everything goes inside. Everything goes inside the facility or the home, and you get two things out of that. You get longevity because it's not being affected by the elements outside, and then you also get appeal so that you don't have any loud outdoor equipment affecting your outside space, and it provides a very outstanding, comfortable environment as well.
Great, Kyle. Well, I don't see any more questions. We had a lot of great dialogue. So if people do have further questions, where can they learn more, and where can they contact you for more information?
please contact me, and my email address is actually here, and we can help you through any questions, anything at all we can help with, and we're pretty well versed on from the beginning phases of design all the way through the end. So we just give us a call, or shoot us an email. We have a whole inside sales team and outside sales team, designers, application designers rather, that can help through the process and just see if geothermal itself is a good fit for your project. And of course I'm going to be biased, but we truly believe that it always is. We just have to put the numbers towards it.
All right, Kyle Smith, thank you for your time today. Thanks everyone for joining us. Mallory, thanks for sticking around and answering some of those questions behind the scenes. Have a great week, everybody, and take care.